Multiplying and dividing radicals is our topic for today. So, let's take a look. Yesterday we did a little bit of multiplying radicals, but I didn't make a video. So I just wanted to put this on here. So if we have two radicals, right, fairly simple, we can combine them into one as long as we're multiplying. And then we can actually multiply those numbers. And what we observed yesterday was that sometimes when you do this, you then have to simplify your product. For example, the simplest example would be this. If I had the square root of 2 times the square root of 2, we could say that's the square root of 2 times 2, which is the square root of 4, which is 2. But that's a really long way of basically saying, oh, the definition of a square root is the square root times the square root equals the number. The square root of 2 times the square root of 2 equals 2. Right? But sometimes it's not quite that obvious. What if I had something like the square root of 5 times the square root of 10? Neither of those can be simplified on their own. Not sure how well this is showing up. Let's try a different. Oh yeah, look at that one. Okay, square root of 5 times the square root of 10. I can't simplify the square root of 5. There's no perfect squares in there. I can't simplify the square root of 10. There's no perfect squares in that. But when I multiply these together, I'm going to skip that intermediate step. I get the square root of 50, and in 50 there is a 25, which I can simplify as 5. So in some cases, and you can actually tell if you are really paying attention, this technically is the same as the square root of 5, and then 10 has a 5, which goes with that one and a 2. But whatever process you want to use, it doesn't matter to me. The main thing is, if you end up with a number that needs to be simplified, if it has any perfect squares in it, you simplify it. So if I had something like the square root of 8 times the square root of 2, you guys probably see already that 8 has a 4 in it. So I could simplify that right now. I could say 8 is 4 times 2. The square root of 4 is 2. So I really have 2 times the square root of 2. Right? That became that. And then I have another square root of 2. So then I can combine these. I cannot combine the 2 with the numbers in the square roots. The only thing that I can combine are things that are under square roots. Right? So the 2 and the 2 can combine. Then I've got 2 times the square root of 4, which is 2 times 2, which is 4. Yeah?
Would you multiply the, like, if it was like 2 times the square root of 2 times 2 times the square root of 2, would you multiply the 2's together 2?
Uh-huh.
Okay.
Yeah.
So it would be like 8.
So sometimes you might have to use the commutative property. Let's write that as an example. If I had something like this, 5 times the square root of 3 times 2 times the square root of 6. I'm going to commute the 2 and the 5 next to each other. These are all being multiplied. Remember, I can always put a little dot there if I want to. And the commutative property says, well, I can move this 2 up here with the 5. So I've got 2 times 5 times the square root of 3 times the square root of 6. And there's a lot of ways to proceed from here. There's not a correct way. As long as you end up with the most simplified form. So 2 times 5 is 10. 3 times 6 is 18. But 18 has a perfect square in it. 9 is a factor of 18. So I would actually pull out the 3, and then I would have 10 times 3 is 30, and what's left behind is just the 2. 30 square roots of 2. Questions about this one? This is pretty much as complex as they'll get for us. I'm not going to do any multiplying that's much more complicated than that. What do we mean by dividing radicals? Well, we mean a couple of things. But mostly what we mean is this. If I have a fraction with a square root in the denominator, I have an irrational denominator. I have a denominator that is irrational. And in Algebra 1, we don't really allow irrational denominators. We don't like our denominator to be an irrational number. The numerator can be irrational, that's fine. So how can we transform this into a fraction that does not have an irrational denominator? Do you have an idea? Well, we can't just flip it, because then we changed it. We can't change the fraction.
So we multiply it by the square root of 2 over 3?
Yeah, that's exactly what we're going to do. This is 1, right? Square root of 2 over square root of 2 is 1. So if I multiply times this, am I changing the fraction? No, I'm just multiplying it times 1. But when I multiply it by this, I still have an irrational numerator, or I now have an irrational numerator, but the square root of 2 times the square root of 2 is just 2. It's just 2, right? It's the square root of 4, which is 2. Square root of 2 times the square root of 2, right? Square root of 4, or 2.
Also, if it was like the square root of 100 times the square root of 100 over the square root of 100, it would be like the square, it would be 100 over the
Yeah. The square root of anything times the square root of that same thing is always the thing. Square root of x times the square root of x is x. Okay? So we're kind of using this trick, and we call this rationalizing the denominator. We're using this trick to rationalize the denominator. Yeah.
Which one is that easier to solve, that one? Oh, because it's not, it's a numerator.
It doesn't have an irrational denominator. And I don't want to really go into anything other than that right now. Yeah. Alright, so what if I had something like this? 5 over the square root of 3. Give you a hint. I'm going to multiply that times something.
Oh, then the square root of 3.
Just like this?
No, never mind.
Over. So again, multiplying times 1, I'm not actually changing my number. I'm just changing how it looks. Up top, I've got 5 square roots of 3. Down bottom, I've got 3. And I'm done. This is pretty simple. However, there are times when it gets a little bit more complex. Not too much more.
Like in the top and bottom.
Well, not for us. What if I had something like this? What would I do there?
Simplify it?
How?
Divide everything by 2.
That's a good idea. The square root of 6 cannot be divided by 2.
Oh, you'd simplify the 6 and then divide the 2?
But you can't simplify.
I'm going to start off doing the exact same thing that I've been doing, actually. I like the way you're thinking. If I could find a way to simplify this, but the 6 is inside that square root. It's like inaccessible by this 2. Remember, the things in the square root can't really combine with the things out of the square root. Right? So I have something outside of a square root and something inside. There's not really a good way to combine those right now. However, when I do this, something happens. Now all of a sudden I have 2 over the square root of 6 over 6. Now there's a 2 up here and a 2 down here that I can divide by, right? So I can cancel that 2, cancel that 2, and I'll just end up with the square root of 6 over 3. Which is kind of weird if you think about, like, so we're saying that 2 divided by the square root of 6 is the same thing as the square root of 6 divided by 3? Do you believe that? I mean, you should believe it because hopefully you understand that you know what we just did. But you could always plug it into a calculator to try it. So if I did the square root of 6 divided by 3, I get this number. And then, oops. And then if I do 2 divided by the square root of 6, oops, 2 square root of 6, I don't think I understand how to use the memory on this calculator. The square root of 6, okay. Square root of 6 is 2.4494897. Okay, so 2. There we go. And then I get the same thing.
Oh yeah, I'll see you when you talk with them on.
Are you also going to be solving these on the homework?
Yeah.
Yeah. So, anyway, if you know how to use your calculator, you'll probably have an easier time than I did. But you can always prove to yourself that these are equal by just typing them into a calculator. 2 divided by the square root of 6 is the same thing as the square root of 6 divided by 3. Believe it or not. It sounds weird sometimes. Now, and you'll also see them sometimes with more terms. So what if I had like this? 2x times the square root of 2 divided by 3 square roots of 8. What are we going to do here? What would you do with that one? The first thing I would do is simplify the square root of 8. The square root of 8 is 2 square roots of 2. So I really have 6 square roots of 2 down bottom if I combine the 3 and 2. So I've got 2x times the square root of 2. Actually, I want to change this just for, sorry, I didn't think this one all the way through. Over 6 times the square root of 2. The only thing I really care about is what?
The irrational number?
Yeah, which irrational number? This one right here, right? I only really care about the square root of 2.
Oh, so you multiply everything by the square root of 2 over the square root of 2.
I just multiply everything times the square root of 2 over the square root of 2. That's the only thing that I'm looking at when I decide what to multiply it by. I'm just looking at this square root in the denominator. Nothing else.
Oh, so it'd be 12.
So then I've got 2x, the square root of 3, and the square root of 2. Well, these two can combine, right? What is the square root of 3 times the square root of 2?
The square root of 6.
The square root of 6. So I've got 2x times the square root of 6. And then down bottom, the square root of 2 and the square root of 2 make, they make 2, and then 6 times 2 makes 12. Am I done?
No.
I don't have a square root in the bottom anymore.
So you're done. Oh, but you can substitute. Oh.
There's a 2 and a 12 that can cancel. 12 divided by 2 is 6. So I've got x times the square root of 6 over 6. Can I cancel the 6 and the 6 now? No. Because remember, the square root of 6 is not 6. The square root of 6 is whatever weird number that I couldn't figure out how to store in the calculator's memory. It was like 2 point something. 2 point something does not cancel with 6.
If you get rid of the square root on the top, wouldn't there be a square root on the bottom?
Right.
Oh, okay.
So if you tried to get rid of this, then you'd have a square root down here.
It's never ending.
Yeah. So that's why we have to leave it somewhere. We've got to leave our square root somewhere. We leave it in the top. Okay, what questions do you guys have about this? What questions do you have about?
How do we solve that?
Well, there's nothing to solve here because it doesn't equal anything.
Oh, okay. Wait, so
If
on
you
the
wanted-
bottom, wouldn't it?
That's your answer.
Okay.
Yeah. I mean, if it said equals 1, then you could solve for x. But we're not quite there yet.